Hello friends, our today's question is group anagrams. So in the previous question, valid anagrams, we have checked whether a given string is an anagram of another string. Okay, so in this question we are given an array of strings. Okay, group the anagrams together. So in this question what we have to do, we have to group all the anagrams together, and you can return the answer in any order. We have to group all the anagrams and we have to return the answer, and that we can return in any order. Okay, so like previously, an anagram is a word or phrase formed by rearranging the letter of the different word or phrase, typically using all the original letter exactly one. Okay, so what is anagram is like like okay, what is anagram? Like we have eat. Okay, so this is, let's see, this is original string and we have created a new string by using all the characters of the original string. So we can say that yes, this is an anagram of this original string. So anagram string is formed basically by using all the characters from the original string exactly once. Okay, so this is anagram, and in this question what we have to do, we have to group all the anagrams, similar anagrams together. Okay, so like in this case we have this example one where we have eat, tea, ten, at, net, bet. Okay, so here bet is bet does not any no string is anagram of bet, so bet is single, or bet has appeared single. But net and 10, these are anagram of each other. Similarly 8, eat and tea are anagram of each other. What what they have in common? Like they have eat, tea and at. Okay, so these three are anagram of each other. So how we are saying these are anagram of each other? Like they have a frequency as 1, t frequency as 1, and e frequency. Like all the character in these three strings have the similar frequency or the similar word character count. Okay, so we are saying that these three are anagram of each other. Okay, in the same way 10, and in the similar way this 10 and net. Okay, so they have T frequency as 1, A frequency as 1, and N frequency as 1. So we can say that these two are anagram of each other. But this is bet, this bet does not have any string which contain a similar character count same as this. So this is not having any anagram in the given string. Okay, in the given set of strings. Okay, so okay, basically we have understood the question, like what we need to do here. So like okay, what is the approach that we can follow is like here to solve this question is like okay, so the simple approach is like comparing each string, okay, and finding whether it is a valid anagram or not. Okay, so this is the first approach that what we have done in the previous question. In this previous question, valid anagram, that approach we can use here. Okay, and we can find out all the valid or similar anagrams. Okay, and second approach is like okay, let's take these two example, eat and tea. Eat, eat and tea. Okay, so if let's say let's short these strings. Okay, so if we have short these strings, so this will be a e t. Okay, and this will also be a e t. Okay, so in anagram string, if two strings are said to be anagram, okay, if if we short these two strings, so they will be similar, they will be same. Okay, so they will be same in this case. Like is this is the s1, okay, and this is s2. Okay, so this is s1 string, this is s2 string. So if we short these string, then they will give you similar result. Okay, so this we can conclude. Okay, like whatever the valid pair of anagrams will be there in this, if we short each one of the string, they will be similar. Okay, so what we can use here is we can use map here. Okay, okay, so what we can do is here, like we can take particular string at a time. Let's clear this for shake, just a second. Yeah, okay, so like we have created a map. Okay, now what we will do, we will map each string, we will short each string and map its similar map its corresponding anagrams, okay, with them. So what we can do, like eat, okay, we have taken this at a time, so we have shorted, so it becomes a e t. Okay, So this is not present in this, we will check whether it is present in this map. If it is not present, we will make a new pair, and if it is present, then we will append the current value to the corresponding key. Okay, so let's say a e t. Okay, and we will map it to eat. Okay, what is the actual value? Okay, now let's say we move to this t, so again we will sort, so it also become aet. Okay, so aet is already present, so we will append this t into our value of this aet, so it becomes teat. Okay, now it is 10, so let's sort this, so it becomes a and t. So this is not present in our map, so it becomes a, so we will initialize it, so a and t, so it will have the value of 10. Okay, 10. Okay, now ate8, so we will short it, so it becomes aet, so it is already present in our map. Okay, so what we will do, we will append that value to the append this value to this aet value. Okay, so it becomes ate. Okay, now this is net. Okay, so if we will short this, so it become a and t, so a and t is already present in there, so we will append this value to the value of ant, so it becomes net. Okay, and at last we have bet, so if we short this, so it becomes a b t, so it is not present in this, so it we will add this key value pair in this, so it becomes bet. Okay, so what we have valid and we have pairs of valid anagrams. Okay, like this is one pair, this is one pair. Okay, this is another pair, and this is another pair. Okay, so what we will do, we will return these value. Okay, so this is our string, so and it is already mentioned you can return the answer in any order, so whether we return first this, then this, then this, or either first this, second this, and third this does not matter. Okay, so this is a simple approach, like what logic we have implemented here is like, if s1 and s2 are anagrams or anagram, then if we short s1 and if we short s2, then these two will give us the same string. Okay, so the same logic we will implement here. Now let's look for its code. So first of all, we will initialize, we will make a vector of a string. Okay, vector of vect over vector of a string. It will contain our result. I think one minute extra. Vector of a string. Okay, so it will contain our result result. Okay, then what we will have our map, that will correspond to a string, comma vect or vector of strng string, so we can set container. Okay, now for each string in strs stars, okay, what we will do, first of all we will keep a variable, like let's say key is equals to str string, then what we'll do, we will short key dot begin key dot end. Okay, so what we have done, we have taken key particular string as a particular string, we have taken this in key, and then we have sorted that key. Now what we will do, we will first of all we will check if it is present in a container or not. If container container dot find find key, container find key is equals to container container dot end. If it is not present, then what we will do, we will make one container for key is will have the value of str. Okay, this is our original string. Else what we will do, contain your container key dot push back str. We will push back into, like this is the case when we have t, we already have at and its value is t, so this is a vector of a string. Okay, so we will push back a t into this. Okay, so that the same we have done. So we have found we have created our map with the desired anagrams. Okay, so what we have to return a list. So what we will do, a list of list, vector of vector. Okay, so we will take the second auto group, group from contain your container. What we will do, result dot push back group dot acco and second. This is the method of vector map in C++. Return resu early result. Let's run this. So it is accepted. Now let's submit and try. So it is accepted. Now regarding its time complexity and space complexity, so let's say we have m, what is we have length of each string as m. Okay, and total number of string, let's say we have n. So like for sorting we will take m log m time complexity, and we will do it for each string. So we can say that our time complexity will be n into m log m. Okay, now for space complexity. Okay, space complexity, so we are using this vector and this ordered map. Okay, so it will contain a string and number of strings we have n, so n into m. So space complexity will be n into m, time complexity will be n into m log m. Okay, so this is a solution. Okay, thank you for watching.